Hello and welcome to the next episode on my tutorial series, Subtractive Synthesis on Various Synthesizers. In this episode we're going to be discussing envelope generators, but first let me recap what we've covered so far. First, we covered the overall architecture of a subtractive synthesizer, and in each episode we've used a different synthesizer and we've discussed the individual sections of that synthesizer and describe the function in turn of each. So far we've covered the oscillator section, the mixer section, and the filter section. So the next section we're going to be covering is the envelope generator section. So without further ado, this is the Synth Pro desktop by IK Multimedia. Let's start by talking about what sections are available here. Well, in this case, the controls are done by virtue of these four knobs, and the meaning of those knobs in any context is described by the illuminated text in this table. So we have 3 oscillators with 2 pages of control, a mixer section, a filter section, 2 envelope generator sections, an LFO section, a modulation section, and an effect section. So what are we going to try and design here? Well, since envelopes are what we're discussing, I would like to start by designing a plucky sound. I think a plucky sound is very well differentiated from the gated sounds we've heard so far. That's to say, the sounds we've heard so far have had a sudden onset, have continued at some fixed level, and then dropped off very rapidly. An envelope is a device that allows us to define a gradual ramp for the onset of the sound, some sort of motion once the sound starts playing, and a gradual decay of the sound as the key gets released. Those stages are known as attack, decay, sustain, release. So unlike in the previous episodes where we jumped straight to the oscillator section, let's jump to the amplifier section and let's understand how the envelope works. So an ADSR, or attack, decay, sustain, release envelope, has 4 stages, and each stage has 1 parameter. The attack and decay stages and release stages, the parameter can be thought of as a time. In other words, how long does it take for that phase to complete? The meaning of time in attack phase is how long it takes to reach 0 volume or 0 modulation level to full modulation level. Numerically, that's called 127 in this synthesizer. The release stage defines the amount of time from when the key is released to the modulation amount decaying back down to 0. The sustain level sets the level at which, when the key is held for a long time, the level will be maintained at. The decay stage is the amount of time it takes once the attack reaches full level for the sound to decay down to the level set in sustain. So the classic shape is attack, decay, sustain, release. So rather than just talking about that, let's hear it. At the moment, effectively, we have no attack, no decay, no release, so maximum sustain. So the sustain is basically vertical, there's no decay phase. The attack is vertical, no decay phase, sustain, and the release is basically vertical. Let's turn the release up. So now, vertical attack, no decay, continuous sustain, sloped release. Let's turn release all the way down, and instead let's turn attack all up. So with the attack up, we can hear a sloped attack, no decay, continuous sustain, instantaneous release. Finally, let's talk about what the decay section does. So the decay, as I said, runs from when the attack finishes for a certain amount of time until it hits the sustain level. So if the sustain level equals the attack's terminal level, you won't hear anything. So let me set the sustain to 50%, while the decay and attack are 0. You'll hear the sound is very quiet. Why? The attack is so short, the decay is so short that all you hear is the lower sustained level. But instead of having the decay 0, let's set some decay time. So, almost instantaneous attack, gradual decay, sustain, instantaneous release. So let's use all of these phases, the stages now. So, a little bit of attack, a longer decay, continuous sustain, and a little release. So that is how the envelope functions. Let's go back to our sound design. We're talking about a plucky sound, like a plucked string. So from my perspective, a plucked string, in truth, there is no concept of decay and release being different, because once you pluck the string, you only interact with it once. But from a usability perspective, I would like a pluck to have some difference between if I hold the key and if I release the key. But in either case, the plucked sound should decay to 0, whether I release the key or not. So because of that, I'm going to set the sustain level to 0. A plucked string happens almost instantaneously, so I'm going to have almost no attack. Sometimes if you set attack to 0, you can get a slightly unpleasant clicking artifact, especially in the bass register, so I didn't actually use 0 attack, I used a very, very narrow attack. So I think that's a bit short, so let's extend the decay time. I think that's probably good. I think I would like, when I release the key, for the sound to stop a little faster. So one thing you may have noticed just then, if I play legato, the envelope only sounds once. This is kind of inconvenient, because for a plucky sound, I'm imagining if I'm plucking a string, there is no concept of legato string plucking. So what I want to happen is for it to re-trigger. Now, there is a re-trigger setting in the menu, but what's actually happening here is legato mode is enabled. So I'm going to change from legato to mono. So now if I play legato, each note that I play is going to re-trigger the envelope. Okay, so we have something of a plucky sound going on there. Let's go back and let's adjust the waveform so as it sounds the way we want it to sound. So in the oscillator section, we can see we've got 3 oscillators. Each oscillator is the same. They have a morphable analog oscillator from triangle to saw to square to pulse. So let's listen to those quickly. Saw is the triangle is quite clean. The saw is buzzy. And then as we get to square, it gets more of a hollow sound. And then that sound gets thinner. People sometimes describe it as a reedy sound. So you can think of that as something like a woodwind. That one more brassy. This one a bit more like a string section. And this one cleaner. So maybe I'll go for something between a triangle and a saw. Now, I do have 3 oscillators available, but one of the things to think about in sound design is it's easy to assume you should always use all the oscillators. From my perspective, I would rather start with fewer oscillators and introduce more if I need to. So let's look in the mixer section. I'm going to turn down all the oscillators but one. We also have noise. So noise doesn't necessarily make sense for the entire sound, but one of the features of a plucky sound that I would like to introduce here is a transient at the beginning of the sound which has a slightly different timbre to the rest. So we're going to use the filter envelope for that, but before we do, we're going to look at the filter section. So this synthesizer actually has 2 filters, and each of the filters has a set of modes available. So let's have a look here. We can have the second filter bypass parallel, serial, or a series of different modes, all of which can be serial or parallel. So what this means is there are two filters and they can be side by side running on two separate copies of the signal which gets mixed afterwards, or they can run one in front of the other. In the same way as I didn't need both or all three oscillators, I don't think I need both filters. If I run them in filter 2 in bypass parallel, there will be an unfiltered copy of the signal and a filtered copy of the signal running side by side, which is not what I want. So I'm going to set filter 2 into bypass serial. That means it's going to go through one filter, then the same signal will pass through the second filter, but the second filter won't do anything. So we're going to only hear the signal as filtered through filter 1. Filter 1 has a range of different modes from bypass to high pass, 180 and 0, low pass 180 and 0. What does this 180 mean? Well, when a signal passes through a filter, sometimes the signal comes through intact. Some signal architectures invert the filter, which is the equivalent of, in a sine wave, shifting the phase of the sine wave by 180 degrees. Because we're only using one filter as opposed to two in parallel, the phase is irrelevant for our purposes and will not make any audible difference. But it could make a difference if we were running them in parallel because we could get phase cancellation. So I'm going to use the low pass filter here. The other parameters we have access to, we have the capacity to link the two filter frequencies so they have a single cutoff frequency common to both, in which case we have a spacing parameter to choose how far apart those two frequencies are. In this case, since we're only using one, it's irrelevant for our purposes. We also have the amount of envelope going to filter 1 and filter 2. The envelope routed to these is the filter envelope. So what I'm going to do now is I'm just going to turn the cutoff down to the way that I would like it to sound in the tail of the sound. So in other words, after my transient, when the pluck continues, this is what I want it to sound like, because when I modulate the filter, it's going to rise from there. So now I'm going to also set the amount of modulation of the first filter by the filter envelope to maximum. We may dial this back afterwards. For the second filter, it's off, but it seems neater to set this to 0. If I'm capable of that, that's fine. So now let's look at the filter envelope. So what we want here is a very short pluck. So what does that mean? Okay, so let's try now turning down the amount of modulation that we had here. So you may notice that the minimum amount of rate, the adjustability of the length of the filter envelope at very small scales, is not super fine. Some synthesizers have very fine adjustment of the time parameters in the envelope. Some of them it's much more coarse. I feel like this is a bit coarse. So let's experiment with resonance. Let's try upper register. I'm feeling like now the amplitude envelope is a little long. So now we have that little attack. Let's experiment with more noise. So now we have that little transient caused by one of the envelopes adjusting the filter in a quick spike and then back down to 0. So it's opening and then closing the filter very rapidly. And we have our main envelope, which is a decaying envelope. So I think this takes us to about where I wanted to go. Hopefully now you have a bit of understanding of envelopes and you understand how those can be used alongside the filter, alongside the mixer section, alongside the oscillator configuration to achieve a different sound. So thank you for watching. I hope you've been enjoying the series and I hope you continue to watch the series. But for now, goodbye.